Hi, pure mathematics for graduate students. Now we talk about some profound courses. In the fundamental functional analysis, we deal with the linear operator. Now, in the profound course, we will deal with nonlinear functional analysis or unbounded linear operators. There are some hot topics such as Banach algebra, C-star algebra, von Neumann algebra. We introduced this book by Carlson and Lingrus. Fundamentals of the Theory of Operator Algebras. Ergodic theory. This is a textbook for the ergodic theories. Differential topology. We introduce a classical textbook, Differential Topology, by Maurice Hachette. We also introduce this classic book, Topology from the Differential Viewpoint, by the John Milner, Riemannian Geometry. There are a lot of textbooks for this subject. Symplectic Geometry. Foliations. There is a book, Foliations, by Kendall and Colin. Characteristic classes. Here is a book by Milner and Sheaves. Fibre bonders. Here is the textbook for fibre bonders. Differential forms. We introduce the book by Booth and Hu. Differential forms in algebraic topology, homology, cohomology. This is a classic book for homology. Homological algebra. There are some great reference books. This one and this one. Introducing homology. Then we must introduce the category theory. There is a classic book by the founder of category theory, Maclaurin, Categories for the Working Mathematician. We also introduce a book, Cohomology of Groups by Braun. Homotopy theory. There is a book for homotopy theory, Homotopical algebra. Here is the reference book for homotopical algebra. K-theory. In geometric view, K-theory is for vector bundles. We have several great references for K-theory. For example, here by Adia. This one by the Hachette. We also have algebraic K-theory. There are some great references for algebraic K-series. For example, this book by Rosenberg. And this book by Weber. You can find this book online. There are some subjects for some specific algebras. For example, Koszul algebra and some quadratic algebras. Hyperbolic manifolds. This is the reference book for hyperbolic manifolds. Hyperbolic geometry can be applied in the physics. For example, general relativity by Einstein. It also can be applied in some mathematical fields. For example, in number theory. Here is a subject, discrete groups that are often related to the hyperbolic manifolds. This is a book, Arithmetic of Hyperbolic Three Manifolds by McLachlan and Reid. Here is the reference by Thurston, Geometry and Topology of Three Manifolds, and lectures on Thurston's book, Hyperbolic Manifolds and Discrete Groups. Here, we introduce another book, The Geometry of Discrete groups by building Lie theory, including Lie groups, Lie algebras, and representations. Here is a textbook for Lie theories. Representation theory. Usually, we are interested in the representation of finite groups or representation of Lie groups. This textbook is for the representation of finite groups. And this one also for the finite groups is a good book for representation of Lie groups. Number theory. Normally, number theory includes analytic number theory and algebraic number theory. For analytic number theory, we have some references. Here is one, this one, and this one. For analytic number theory, distribution of prime numbers is a hot topic. For algebraic number theory, we introduce the book Number Fields by Daniel Marcos. Commutative algebra. We introduce two invariable books. Introduction to Commutative Algebra by Kia and McDonald. Commutative algebra with a view toward algebraic geometry by Heisenberg. The people study commutative algebra are for studying algebraic geometry. Next, we will talk about algebraic geometry. Algebraic geometry. In algebraic number theory, we are very interested in the integral closure. That is, ring of algebraic integers equipped by Zariski topology. We get a topological space called variety. Then we have the morphism for the varieties. Varieties plus morphism form a category. By Grothendieck, Seher, and other great mathematicians workers. We have a theory of the schemes, Sheaves, Cohomology, are complex for studying algebraic geometry. There are two well-known textbooks. Here is the Hutchinson's book, Algebraic Geometry. Another is a Shafarevich book, Basic Algebraic Geometry. This book has two volumes. Volume 1 validates in projective space. Volume 2, schemes and complex manifolds. There are many other good books. For example, this book, Algebraic Geometry, deal with algebraic curves. Algebraic curves, in fact, can be regarded as compact Riemann surface. This is a manifold. But we know the space varieties is not manifold. In fact, this space is not Hausdorff. There is a classic way to study the algebraic geometry by studying Riemann surface. Here, we introduce some references by some great mathematicians. Principles of algebraic geometry by Griffith and Harris. When I talk the course Riemann surfaces, the professor used this book to teach Riemann surfaces. This book, a second course in algebraic geometry by Heisenberg and Harris, is the book for intersection theory. And the intersection theory by Fulton. Riemann surfaces. We have a specific book for Riemann surfaces. Here is the one. Here is the one for algebraic curves. This in fact compact Riemann surfaces. This is another book for the Riemann surfaces. In algebraic curves, we are particularly interested in elliptic curves. Here is a very good reference for the elliptic curves. Modular forms. Modular forms play significant role in proving the Fermat conjecture. Here is the very good book for modular forms. And here is a classic book for the number theory, including modular forms. There are also a lot of subjects I don't understand well. I finished an introduction to the profound subjects in Q mathematics here. Thanks for watching. Bye.